So thank you. This session is again focusing on the power of nature's materials. The exciting part of this panel for me is this is really about the translation of the technology. So, a lot of times we get together as scientists, we're talking about the research, how interesting some of the ideas are. But on this panel, we have individuals that are bringing in the entrepreneurial aspects and turning these ideas into products, so the true innovation. And that's really has been at what the core of Great Lakes Biomimicry's founding is: how do we translate the ideas in nature into helping businesses and sustaining the entire activity through that. So our first presenter is Sissi Liu from MetalMark Innovations. She'll be talking about from butterflies to the air purifier, one company's journey from nature-inspired materials to disruptive indoor air quality solutions. Here we have someone that is very passionate about solving society's complex problems, a 20-year career in climate tech and sustainability. But what the exciting part and the talent of our speakers is that they not only have that interest in biology and nature-inspired, but they have experience in tech startups, founding companies as the CEO, in this case, of MetalMark Innovations, and trying to solve global air pollution crisis.
Thank you very much, John. And thanks, everybody, for coming this morning to be a part of this event. And thanks to the organizers for having me. I am a non-engineer and non-scientist, so to be included is a real honor. So yes, I'm Sissi Liu. I'm CEO and co-founder of MetalMark Innovations. So my interest in biomimicry started almost 20 years ago when I came across this little book called Nature's Operating Instructions. I don't know if anybody has heard of it before. It was very small with lots of interesting articles about how people were already thinking of using nature's intelligence to solve very important environmental issues, like using plants to suck up the toxins from soil. And I got so excited about this idea that I went out and bought, well, I didn't go out. I went on Amazon and ordered a bunch of these books and started gifting them to friends and family and colleagues. And so as John mentioned, I've spent about 20 years of my career in climate tech. And so during that time, I've come back and again to this theme of biomimicry. So I've had the privilege of working with companies that are using biomimetic approaches to solving environmental and climate problems. One company where I was doing business development, we were using cyanobacteria as the engine to to convert carbon dioxide directly into drop-in diesel fuels. In another company where I was on the board of the company, they were using a DNA material as the templating agent to create water purifying filter membranes. So that all of those many experiences led me to MetalMark. That's where we have now invented the world's first self-renewing, self-cleaning air purifier. And I'm really happy to announce that we recently received our first patent on the technology. So a few things about what it does. So currently, many people have now, because of COVID, come to know about indoor air quality concerns. But actually, this issue expands far beyond airborne viruses and infectious aerosols. Just in the last few months in Boston area where we live and work, we've experienced wildfire smoke that covered much of the New England area and all the way down to Georgia, right? And so these are climate change aspects that are starting to become more of a real problem that we experience from year to year and probably more frequently in the future. And so as an example, these wildfire smoke pollutants infiltrate into the indoor space, and most people don't understand how this works. And for the most part, the indoor environment actually concentrates pollutants like volatile organic compounds and very small particulates in the ultrafine and fine ranges, smaller than the PM 1.0, which is one micron in diameter, down to 0.1 and smaller in the nanometer size of particles. And these pollutants, actually in the panel before, they were talking about certain environmental factors that affect Parkinson's. Well, there's actually epidemiology studies that show the effect of ultrafine particles on dementia and potentially changing and damaging our DNA. And so these are the new factors we're living with, both from our own activities indoors and also because of our more global impact on climate change. And so indoor air quality is becoming more and more of an issue. And so our solution is targeted towards commercial buildings, specifically in school classrooms and conference rooms in offices, hospitals, and healthcare environments. And each unit is designed for treating up to 1,000 square feet of space with up to 3 air changes per hour. And so what really sets our solution apart from what you have already seen out there is that you can install our system and not worry about changing filters for up to 5 years at a time. So if you own an air purifier at home, you know that typically you're supposed to be changing some type of filter every 3 months, every 6 months. Well, think about it from an organizational perspective. That's a lot of facility management time and cost. The filters themselves are really expensive, and multiply that by the manpower you have to put into it to change the filters. And so what we heard from customers is that this is not really doable from a larger facilities standpoint. And yet many organizations already have small portable air purifiers. And so our solution really helps to solve this problem. And more so in our today's day and age, it's really difficult to find staff and labor to contractors to maintain buildings and systems. In addition, we target this idea of over the lifetime of the product, we can have a lower cost compared to alternative commercial solutions. And it's designed for easy building integration. On top of that, there's actually a lot of energy savings potential here, because one of the biggest drivers for energy use by HVAC systems comes from ventilation. So if you have to cool the outdoor air and recondition it for indoor use or heat it, that's where you have to put the most energy. And so if we can reduce some of that ventilated air from the outdoor, we can start to save energy. And again, as I mentioned before, we have more and more issues with the quality of outdoor air. And so it's not quite as reliable as we've always depended on to be the source of fresh air. And so we are very customer driven, right? So we heard from the customers in facility management in large commercial buildings that say, look, we can't have these little air purifiers sitting on the ground, on the floor, and be kicked around, taking up valuable floor space. So we decided to put it in the ceiling. So it's self-ducted in-ceiling installation, doesn't touch the HVAC system at all. But what it does is it provides data and analytics so that we can provide that insightful information to the key users of the systems, the customers. So the facility managers and people who have to operate the system can make critical decisions when necessary. But we actually didn't start out our journey to go and make an air purifier. We started with an innovative bio-inspired material at Harvard, and my co-founders invented this material based on looking into the iridescent colors found in butterfly wings. And so in butterflies like the MetalMark and the Morpho butterfly, you find this porous natural structure that results in the iridescence. It's not from having some kind of pigmentation that they're iridescent. It is actually from the structuration of the material. But what's really interesting is that it is a single material, chitin, that is an organic polymer And it's just structured in different ways to give rise to a number of functions. For example, the lightness and the strength of butterfly wings to enable the flight of the creature. It's also water repellent. So this very brilliant idea from nature that you use a very simple starting material, but structure it at nanoscale in different ways to enable a bunch of different functions. That was the real concept and starting point for us. And so my co-founders at Joanna Eisenberg's lab were looking into this inverse opal structure to mimic the structure found in butterfly wings, and using this material as the scaffold to then create a number of other structures. So what they did was embed nanoparticles of catalytic material into the interface of what I show on the right. But ultimately, one of the challenges we then ran into was, is it easy to scale? Is it cost effective from a manufacturing perspective? And we also had a hypothesis at the time before going out to talking to customers that people would want to use our material, and it's pretty easy to get them to adopt. It didn't turn out quite to be the case. It was a lot harder and more challenging for them to say, hey, this material can't just be, put into the manufacturing system for all kinds of chemicals. That's not really how it works. And so when we started to think about and conceptualize our air cleaner, we also had to think about, do we need to adjust the material in order to really address the customer problem? And that led us to then start to work on other structures. Again, using the scaffold, but structuring other compositions, other materials in a number of different ways to achieve the outcome we wanted to achieve. And so this material that we now have is low cost, very scalable. We can make kilograms and tons. We know how to scale it to tons per batch. And so we've kind of de-risked it from that perspective. It's also an absorbent as well as a catalyst. And so we started to embed that into filter material. Another idea, though, is that, as I mentioned, our system, it does self-renewal. So that's another idea from nature. Dr. Joanna Eisenberg at Harvard her lab had been studying this type of surface structure in lotus leaves for self-cleaning. But this idea of self-renewal is not, doesn't just apply to lotus leaves, right? This is just surface cleaning. But if we think about all living organisms, there's always some way in which we are self-renewing through metabolism or whatever other mechanisms. And so that's what led us to our self-renewal system. And so during a stage 1 process, which is primarily what our system does, it's just like any other air filtration system. We're filtering, removing the particles that are in the air. And then in a stage 2, which happens roughly once a month, the system goes through a self-renewal, self-clean. And what that does is the system activates the material that's on board, embedded into the filter media, and we break down a large part of the particles and the chemicals that are captured during that stage 1 process. And it turns out that the reason that you have to change filters frequently is because the pressure increases. So as you capture more particles, the pressure increases on the filter. That's one of the biggest reasons you have to change filters, right? And so by self-renewing, we can reduce the pressure across the filter and then keep it in place and operational for a much longer time. We're talking 10x the time of typical filters. And then we didn't stop there. We continue to think about other ways that nature does it better than us. If we look across the plant and fungi kingdoms, there are just vast and abundant evidence of distributed networks and using modular versus collective responsiveness. So above and below the soil, chemical signals are utilized and they change behavior in all kinds of organisms. And so this is a very fascinating aspect that we think about quite a bit. And so nowadays with smart sensors and data collection, we can achieve that similarly. And so we offer the IAQ monitoring, and by collecting the data, we provide the information to facility managers and heads of operations. But more importantly, we can start to optimize the operation of the devices on an individual and network level to save energy, to optimize between indoor air quality for occupants versus other considerations. So in summary, we are very much customer driven because, for translating any kind of material science or technology to the market, you have to listen to the customer as the starting point. And we view biomimicry as multifaceted, multi-scale, and multidimensional. And so we're continuing to evolve our technology and solution in order to better address customer needs and provide those value propositions. And very importantly, another driver for us has always been sustainability. Like how we selected the material. When we were trying to scale, we considered the environmental impact of the starting materials and the potential waste that's produced. And so our switch to other materials is very much driven by that motivation to become more environmentally sustainable as well. So that's it. Thank you very much.